Have you ever rubbed a balloon on your head and watched your hair stand on end? It's a classic party trick, but it's also a fantastic example of electrostatics in action. We've all been there, right? That moment when you become a human science experiment. But what's really going on? It's not magic, though it might seem like it. It's all about tiny particles called electrons jumping from the balloon to your hair. These electrons carry a negative charge, and when they build up, watch out. They want to spread out, causing each strand of hair to repel the others, resulting in that signature static hairstyle. Cool, right? Electrostatics is the study of electric charges at rest. You see, everything around us, from our bodies to the air we breathe, is made up of tiny particles called atoms. These atoms have even tinier particles called electrons, protons, and neutrons. Protons are positive, electrons are negative, and neutrons, well, they like to stay neutral. Usually atoms have an equal number of protons and electrons, making them electrically neutral. But sometimes electrons like to wander. When objects rub together, like that balloon and your hair, electrons can transfer from one to the other. This creates an imbalance of charge, and things get interesting. Static electricity isn't just about hair-raising experiences, it's everywhere. Remember that time you got a shock touching a doorknob? That's electrostatic discharge, a sudden flow of electrons from you to the doorknob. It happens when there's a buildup of charge and a path for it to flow quickly. Lightning is another spectacular example of electrostatic discharge on a much grander scale. The friction between ice crystals and storm clouds generates massive static charges. When the charge difference between the cloud and the ground gets big enough, zap! A bolt of lightning discharges the energy, creating quite a light show. That tiny shock you feel when touching a doorknob might seem insignificant, but it's a miniature version of the same phenomenon as lightning. See, when an object becomes electrically charged, it seeks to neutralize itself by either gaining or losing electrons. When it finds a conductive path, like your finger, it takes it. That sudden flow of electrons through your body is what causes the shock. It's a safe and harmless example of how electrostatics can manifest in our everyday lives. So, the next time you rub a balloon on your head or get a little zap from a doorknob, remember the science behind it. It's all thanks to those tiny zippy electrons.